The world is a wild and unpredictable place. And isn't that absolutely amazing? Products can catch fire overnight. A back-of-a-napkin idea can change the world. An incurable disease can suddenly appear vulnerable. So many wonderfully improbable, never-before-possible breakthroughs are out there, waiting to be discovered. With Amazon Web Services and Intel, you'll be ready for anything. Ready to unlock a human genome, to safeguard our most valuable assets, to improve the way we communicate, to give every human a chance at a better future, to reach new speeds. Because you'll have Amazon Web Services featuring custom Intel technology to drive cutting-edge advancements. Because AWS and Intel engineers have worked together for over a decade to make sure you'll be ready. And because you'll have AWS's most innovative and powerful cloud service platform to help you make the impossible possible. That is the power of AWS with Intel. So go ahead, shatter conventions, explore the unknown, and ask questions that haven't been answered. With Amazon Web Services and Intel, you can charge toward the future ready for anything and ready to change everything.
To prevent technical interference, we would ask you to silence your mobile telephones. Ladies and gentlemen, please welcome Kamini Aisola, General Manager at Amazon Web Services Benelux.
Wow, a full house today. Good morning, Amsterdam, and welcome to the AWS Summit. I think I can speak on behalf of all of my colleagues to say that we are truly excited to see you here. So thank you so much for taking time out of your busy schedules to basically learn about AWS, and more importantly, to learn from each other. This is by far our favorite day of the year at the Benelux, for the AWS team in the Benelux. So let's see. Who in this audience is attending an AWS Summit for the first time? OK, that's really a fair number. I can't, of course, look through the back of the audience. But thank you to all of you. Thank you to those of you who are here for the first time. And to everyone else for taking really, really important moments out of your busy schedules to come in to basically learn. So our approach differs from other technology, sales, and marketing conferences. We're really passionate about learning and skills. In fact, we believe that that's what underpins builders today and will continue to do so in the future. So our objective over the course of today is to maximize the value to you as a learning opportunity, to learn about the cloud, learn about AWS, about our partners and the ecosystem, but most importantly, to learn from our customers. We have over 25 customers who have taken time to share their stories with you. So we've built a great agenda for you with over 50 breakout sessions, with a broad range of sessions from business, a business track, right through to technical deep dives, sessions for enterprises, for small and medium businesses, public sector entities, and for startups. Besides the sessions, I'd like to call out the Stella V solar car, which is in the expo area from the Technical University of Eindhoven, and our customer, WAPCO, who will be showcasing their vehicle control systems. So I would advise you all to build an agenda for yourselves that takes into account your particular interests and your experience level. So you can find all of the details in the AWS Summit app. If you haven't downloaded or set it up just yet, or if you need any help, go over to the AWS Village or ask an expert. Now, the fact that we can offer this education and enablement opportunity to so many people free of cost is truly thanks to our sponsors, who have seriously stepped up this year to support us. So I want to motivate you to go over and learn more about what they can provide. A special thanks to our global sponsors, Intel, Datadog, Veeam, and VMware Cloud Health. To our platinum sponsor, Rackspace, our gold sponsors, as well as our bronze and silver sponsors, and our training partners. So please go over and visit them in the expo hall and learn how they can help you. Now let me do a quick business update, just to demonstrate really the momentum that this community is driving. Now, AWS is a large and rapidly growing business, and Q4 of 2018 revenue for the AWS segment increased 45% year on year to $7.4 billion, making it almost a $30 billion run rate business. The cloud is growing, and it's growing at a pace that we could not have imagined possible 12 years ago when we launched our first cloud services. So the numbers on the screen are just an indication. They're a testament to how fast our customers have adopted the cloud to drive down costs, innovate faster, and improve their own times to market. AWS in the Benelux has 4 offices, in Luxembourg, in Brussels, in The Hague, and here in Amsterdam, where we also have 2 edge locations. We are further investing in this area locally to help customers and partners by bringing a range of roles and functions closer to our customers. So in fact, in the areas of account management, solutions architecture, professional services, our partner organization, amongst others. So when it comes to innovation, maybe let me just say a few words about, coming from from Jeff Bezos, as a quote from Jeff Bezos. He has an interesting perspective. So I'm going to quote him, but there are day 1 companies and there are day 2 companies. Day 2 is stasis, followed by irrelevance, followed by painful decline, and finally by death. At Amazon, our single focus is to obsess about the long term. It's not to obsess about products or even life cycle, but really about inventing for customers. It means getting really good at experimenting and getting really good at things such as using data to anticipate and provide for customers and understand what they are doing. So it's a perpetual motion, it's not static, and that's what day 1 means to us. So in fact, it fits really very well into this region, which is world famous for its innovation, entrepreneurship, and global reach. Think about innovations such as the compact disk, the Python programming language, the JPEG format, or even the Flitzpal. Our mission here at AWS is really to amplify this Benelux culture of innovation to drive sustainable success for our customers in the digital era. So previously, some people in the Netherlands have had the perception that the cloud is only used by startups and that larger, more security-conscious, regulated bodies will not use AWS for anything more than development and test environments. A good proof point, in fact, to the contrary, of the acceptance of AWS within the market is today more than 80% of companies on the IEX stock exchange are using AWS in a substantial manner to speed up their time to market, lower costs, support their technical efforts, and expand their businesses globally. We've seen in the past 3 years more customers from sectors such as the public sector, utilities, financial services, oil and gas, and transport companies moving large workloads to AWS. So AWS has tens of thousands of active customers in the Benelux, from well-established and world-renowned names such as Philips, Shell, or Unilever, to household names in the Netherlands, such as Essent, PostNL, and of course, hot startups from the region, such as WeTransfer. Now, let me maybe take this opportunity to kind of zoom in on one of our customers. PostNL is a company that has been embracing AWS for a period of time. PostNL is, probably pretty much everyone in this audience knows very, very well, is the postal and delivery company of the Netherlands and has been so for over 200 years. So PostNL embraced AWS to help them move and run significant parts of their IT application landscape into the cloud. And I'd like to invite onto stage this morning the CIO of PostNL, Marcel Krom, to say a few words about their experience and to share his story with you. So good morning, Marcel. Thank you so much for joining us today. So AWS is now running a significant part of the critical logistical applications for PostNL that are really at the core of your business. We had PostNL on stage 4 years ago. What has evolved since then?
I think 4 years ago we were just a beginner in using the AWS ecosystem. I think in the last few years we have brought all our logistical systems into AWS. I think everyone who has ever ordered a parcel will know how difficult it is to do it at the right time, at the right moment. And we have brought all our systems into AWS, especially our mission-critical systems. I think we also have implemented a very good DevOps environment, so we can release faster, more, and deliver more functionality towards our business. I think that's the second thing. And what we also have done in the last 2 years is to implement a full data lake, where all our data is resisting, and that we can now embed also algorithms into our production.
Well, today PostNL uses AWS for parcel pre-registration, for internal transport management, and for commercial channels. Could you maybe rewind slightly and tell us a little bit about how you started on this journey in the first place?
Yeah, we started thinking about cloud in 2011, and in 2012 we decided to go full cloud. And full cloud is a big step. So we went from on-premise to a full cloud situation, and it took 5 years for this complete migration. And when you migrate all your applications into cloud solutions, it's a big step, because you have to embed your complete ecosystem into these kind of solutions. So in the last 5 years we've done that, and this year we will close our data center, so that's a big step. Next to that, we have thought about everything we can do with these kind of developments, and we are embedding now innovation into our cloud system. And innovation is also brought by AWS. So we have a center of competence, also an AWS center of competence. We are embedding it now to use the full benefits of AWS. I think what also has brought us these kind of developments is that our people are now at the heart of our innovation. And they bring the innovation out of AWS into our company, and it also makes them happier.
Excellent. So, for those of you in the audience who are observing this slide up there with a number of statistics, I think you will probably recognize some of them, but maybe have not realized really the scale and scope. So, Marcel, for you, in which area of the cloud has been the most beneficial for you as a company? What has been the impact on your business productivity?
Yeah, the impact on the business productivity, of course, is huge. You might not be aware of it, but PostNL is one of the most intense data companies in the Netherlands. We do millions of transactions per day to inform everyone where is your parcel. We have to process all those letters, and it's a huge volume, and all the people in the Netherlands are our customers. I think one of the benefits of bringing it into AWS is also about, of course, it's cost, because we are a very cost-intensive company, so we have to save cost always. So it has brought us a lot of cost savings. Next to that, we also see that we can do things very fast in experiments. And in the last 2 months, we had to do a complete check in the revenue management part, and we set it up in our data lake, and it was only 2 weeks' work. And we will now embed that experiment into our normal practice, and that helps us a lot. I think also that what you see is in our discussions, then we do not have any more discussions about how to do it within the infrastructure. IT is not anymore on the critical path out of this perspective.
Okay. That's very interesting that you mention IT is not on the critical path. And of course, one of the trends that we are tracking in terms of the usage of the cloud is in the area of machine learning and artificial intelligence. Could you tell us a little bit about how PostNL is looking at these trends and what you might be using today already?
What we see is that artificial intelligence will have to be at the heart of our supply chain. We think that the supply chain of PostNL will be algorithmized, I think, in 2022. That's our aim, but we have still a lot to do, so we need a lot of expertise for that. But what you see is, for example, we have more than 4,000 retail points, and we know exactly how much cubic meters every retail point has. Mm-hmm. And we also know the volumetrics of every parcel. So we know exactly how much space there is left at the retail point to bring parcels. And we are learning with that algorithm. We will have to learn, the algorithm has to learn, but it's getting better day by day.
Very interesting. Now I have a little question for you about the delivery service. Personally, I have noticed that of late, my PostNL deliveries are really just on time. So they arrive at the point that it's the highest likelihood when someone's going to be at home to receive them. You were talking about AI and ML. Does that have anything to do with this high quality of service that we're starting to experience?
It definitely will have. What we see now is that PostNL is a people company, so the people are at the heart of our business, and we want to enrich our people with artificial intelligence and with knowledge. And I think one of the most difficult things is to have the knowledge of your personal deliverer into our systems. Because we also want you to be happy when the deliverer changes from area or is doing something else, and you get a new one, and that he will deliver you the same customer experience. So to embed that knowledge in our systems is a huge transition. But step by step we are getting there, because we always want to deliver at the right time, at the right place, at the right spot. So we want you to stay happy with PostNL as your deliverer.
Thank you. Now, I think it's been really, really interesting hearing about all of these things that you've done so far. But would you like to share anything in terms of your future plans? I think if you look into the development of AWS, you see that AWS is moving from an infra cloud, because we started with IaaS and PaaS solutions, but we see that AWS with Microservices is heading towards a functional ecosystem. And we are embedding now that functional ecosystem in our software development program. And that's a big step for us to use that kind of microservices, but it will also enable us to take the best out of AWS. But this is a big step, to move from shifting applications to cloud-native applications. That's a very big step. The second one is that I think that the drive for innovation is not only what we think out of PostNL, but also what is being delivered by our technology partners, like AWS. And that driver for innovation we will have to embed and bring it into our company to make more speed in innovation. And that excites our people, myself, and to become a data-driven supply chain, this cooperation is crucial. Well, thank you so much, Marcel. I think we can speak perhaps on behalf of many people that we're really looking forward to experiencing the future of PostNL with AWS. Okay. Thank you very much. Thank you. Bye-bye. So, thank you. So, well, thank you all for, for a few minutes before we now have the keynote. If you have something to share on Twitter, don't hesitate. The hashtag is up there, AWS Summit NL. I'd now like to call on stage Ian Massingham, Director for Developer Technology and Evangelism, who will present the keynote. So ladies and gentlemen, please give Ian a warm applause.
Thank you. Good morning. Morning, Amsterdam. How are you all doing today after Ajax's pretty good performance last night? I was rather concerned that might put a little bit of a damper on today's proceedings, but I was really happy to see that Ajax managed to save the evening and also save today with that reasonably late winner last night. So great job. My name's Ian. I'm in the developer relations team leading developer technology and evangelism at Amazon Web Services, and I'm delighted to be here to dive into the AWS platform in a little bit of detail with you today. Before we get onto that, I just want to reiterate something that Kamini said in her opening this morning, which is that this is primarily an educational event for you, our customers, of course, and I'd really encourage you to get along to the sessions today, learn from the AWS speakers that are here, learn from the customers that are going to be joining us in many of those sessions, but also learn from your peers that are sitting around you and will be around you during the course of the day. There'll be people here that are at various stages of their adoption journey with AWS in the cloud, and it's really a great opportunity for you to absorb some of the learnings that others might already have. It's also a really important event for AWS from an education perspective as well. You'll know that 95% of all of the features that AWS creates for our customers come directly from customer feedback. So we want to hear from you about what we can do to make our platform a better place for you to build and run the applications that are important for you. So please give us your feedback. Please let us know what we need to focus on in order to make you more effective, in order to make our platform more effective in helping you achieve your goals. Of course, that process of continuously iterating and adding new features to AWS is the reason that we are where we are today. We have over 165 different services right now across a really broad range of different categories, from computing to storage, to relational and non-relational databases, to analytics, services for mobile developers, services for customers in the media vertical market, lots of services today for machine learning and artificial intelligence, as well as services that are delivered by actual real human beings. Believe that? Like professional services and, of course, some of the migration services that we provide, and then things like AWS Marketplace as well. So there's a huge breadth of services that have been built over the last 13 years based on this simple process of just trying to build things that help our customers solve problems and continuously iterating in that way. And that, of course, not only leads to new services being created, but it also leads to increasing functional depth in existing services that we already have. And in a few minutes, I'll dive into some of the things that we've been doing in databases, in storage, and information security to add more depth to the platform that we provide. But before we do that, I think it's just worthwhile talking briefly, particularly for those of you that might be new to AWS and the cloud, about AWS Global Infrastructure. So today, AWS Services are available in 20 geographic regions around the world, and those regions are subdivided into 61 availability zones. An availability zone is an independent failure domain comprising one or more physical data centers. And believe me, some of the availability zones have substantially more than one data center in them. We have some very large regions around the world with lots and lots and lots of infrastructure deployed within them. We've also pre-announced plans for 15 more availability zones, which will be spread across 5 additional regions: Bahrain, Cape Town, Hong Kong SAR, Milan, and then just in the last couple of weeks, we announced an intention to launch a region in Jakarta in Indonesia. So we're continuously expanding the footprint that we have in order to ensure that our customers and their customers can access AWS in locations that offer the right regulatory frameworks, the right price performance, the right data locality, and of course the right cost as well, because we try to minimize cost within each region within which we operate, and therefore you'll find that our services are priced differentially depending upon where in the world you choose to use them. This concept of availability zones was pioneered by AWS, and we're still the only provider that offers this capability in every region in the world within which we operate. And this allows customers to build applications that are self-contained within a single region whilst maintaining really high levels of durability and availability for their data. So you can be secure and safe in the knowledge that we will not move your data between regions without your explicit instruction to do so. So that's the underlying AWS platform, the physical infrastructure, global infrastructure platform, upon which all other AWS services are built. Diving into databases, many of you will have worked with relational databases, I'm sure, for many years. But what we're increasingly seeing from customers today is they're interested in having the right databases for the right workload types. And this is one of the reasons that AWS has invested to create a portfolio of purpose-built databases that are intended to solve problems in different classes of use case. And we'll dive into this in more detail later, but we have 14 different services today, which is more than double what any other provider has right now. We've also invested in making it easier for customers to move data in databases in and out of the AWS cloud with a service called the AWS Database Migration Service, which today has helped over 120,000 databases migrate to and from AWS and some of the other services that I've talked about a few moments ago. In storage, we've been iterating for a long time. The first service that we launched back in 2006 was a service called Amazon S3, the simple storage service. And that service forms the basis of many, many data storage use cases that are supported by AWS. But we also have block and file storage capabilities for customers. In file storage, we have EFS for NFS, as well as a service called FSX for Lustre, and an FSX variant for Windows Server. And then in block, we have a variety of different block storage options, satisfying both low latency and high performance use cases, as well as low-cost, high-volume streaming data use cases that you might have for analytics applications, maybe running on Spark or Hadoop, for example. So a portfolio of services for data storage, as well as data transfer, of course. And then lastly, on information security, a hugely, hugely important area for customers. We believe that this is customers' #1 priority in choosing and using a specific provider, and also making a commitment to use the cloud more generally. So this is our #1 priority, AWS. We often describe security as job zero, as the first thing that we start to work on before launching or building a brand new service. And we've invested in things like integration for encryption capabilities here. We have over 116 different AWS services that support encryption of data, for example. And of course, with encryption, the literal key to encryption is key management. So we built another service called the AWS Key Management Service that enables you to either create and store AES 256-bit keys in the cloud, which you can then use to encrypt data with another 54 AWS services, or even to upload your own customer-created keys, store those inside our key management service, and then serve those keys out for encryption use cases that you might need to support for compliance, regulatory, or privacy reasons. And of course, our CTO, Werner Vogels, always says, encrypt everything. So it's so simple and easy to do that with AWS that there really is no barrier to making sure that you've got the right cryptography and protection in place for your data. You shouldn't take chances with your data or with customers' data, and we really believe that this is a prerequisite in enabling you to have that posture and achieve that objective. One thing that we've also seen recently is that security is increasingly becoming a driver of migration. So I've been with AWS just over 5 years, and when I started, it wasn't uncommon to encounter customers that were unfamiliar with the cloud, unfamiliar with AWS. And they would quite often cite information security as something that they needed to know more about before they could commit to move workloads or applications to the cloud. But today, that has completely reversed. If you talk to a customer today that is familiar with AWS, they will quite often say, one of the reasons we're here is much of the heavy lifting associated with information security, associated with compliance, is carried by AWS. We have a high baseline of security and protection upon which we can build our applications, meet our compliance needs more quickly, and do less work in ensuring that we have the right security controls. So there's been a fundamental shift in the way in which customers look at information security in the cloud. I'll come and talk about a few more drivers of migration in a few minutes. But before I do that, I want to invite my first customer guest speaker to the stage. This is a gentleman that's been driving his organization towards a cloud-first approach for many, many years now. Back in 2018, he was recognized as the CIO of the Year here in the Netherlands. He's from Talpa Network, which is a global media company headquartered here in the Netherlands that began working with AWS back in 2013. So to hear more about this, please join me in welcoming Hielke Sprangers to the stage here at the AWS Summit in Amsterdam, Chief Information Officer at Talpa Network. Hielke.
Good morning, everyone. My name is Hielke. I'm the CTO of Talpa, so let's talk innovation. Talpa is a media tech company, and our goal and our mission is to create cool content for consumers, basically for you guys. And we do that across the whole media funnel. In the Netherlands, we own 4 TV stations, 4 radio stations. We operate 150 social channels. We have multiple digital platforms and apps and some highly popular e-commerce sites. And in our sister company, Talpa Media, is airing shows in 180 countries. And for example, The Voice in China is attracting 500 million people per show. And by the way, this is my boss, John de Mol. For Talpa, technology is the driving force behind innovation and growth. So for us, the question is, how can we innovate ourselves constantly with just a 0 and a 1? And for this, we have built one single big technology platform in the cloud, and to power and scale all our digital platforms and apps across all channels, all devices, and all countries. So we're 100% in the cloud, our backbone, since 2013, and it's also powered 100% by AWS. And we are using more than 50 AWS services in our backend, so we're all in. And this enables us to fully focus on tech innovation for our consumers. And I would like to show you one of those innovations, FootballTV. Obviously, artificial intelligence or machine learning will change our life and our work massively in the coming years. And for us at Talpa, we have to make all our services smart and intelligent with machine learning. And in fact, FootballTV would not even be possible without machine learning. So what is FootballTV? FootballTV is an online platform for live broadcasting of amateur matches in the Netherlands. And we're going to live stream 80,000 football matches per year online. And in the back, you see some impressions of the app. You can just download it. It's for free. And we're at this moment already live at 100 clubs. If you want to live stream 80,000 football matches, you have to automate everything. Everything, because obviously you cannot send a camera crew to 80,000 football pitches every year. So you have to automate the scheduling of the matches, the registration of the matches, the live streaming of the matches, and even we want to go to automatic highlight detection. Let's take a look at a video clip of AI video registration. In this clip, you will see 2 algorithms at work. First algorithm is ball tracking. So where does the AI think that the ball is? And the second algorithm is the camera movement algorithm. So based on the ball position, the camera movement and the zoom level is calculated. Let's take a look. So I particularly liked the last part of the video, because there you see the camera, or the virtual camera basically, zooming into the corner of the pitch. So you need a very accurate ball tracking algorithm, otherwise you will just zoom into an empty part of the field. And the algorithm is learning and learning, because we get new data all the time, we are improving all the time, but I also have to say and to admit that we also still see some mistakes. Sometimes a bird is flying by and then the camera thinks, oh, that's the ball. And we still have some cases that we have bald football players, no hair, and the AI think, oh, that's a nice tiny spot. Here in the back you see the standard camera setup. We use 2 basic dome 4K security cameras attached to a single pole, and one for the left part of the field and one for the right part of the field. And in the end, so you have 2 camera streams. They are stitched together. You see here the overall panorama frame. And on this panorama frame you see 3 things. First, again, where's the ball, according to the software? Secondly, where are the players, according to the software, because we're also doing player tracking. And then the final director cut for live streaming, the final shot. Back to AWS. As mentioned before, we are making use of over 50 AWS services. And also for FootballTV, the whole backend is running on AWS. Let's focus on one specific service that we particularly like, AWS Lambda. So we use serverless computing to power the backend of FootballTV. And switching to the cloud back in 2013 was one thing, but switching to serverless is another step. And that's very nice, of course. Also being a software engineer myself, I want to write code, so let's get rid of all the hardware and no server administration anymore. FootballTV, we are using serverless to do orchestration of the live stream resources, and of course the additional benefits are that we don't pay for idle time. FootballTV is just one of our intelligence services, as mentioned before. We want to apply AI, machine learning, to make all our services intelligent. And finally, I would like to show you a track record of our innovations servicing hundreds of millions of people worldwide with cool interactive content, and it's all powered by AWS.
Talpa Network is a media tech company where technology drives innovation and growth. Our teams created the following groundbreaking innovations. First-time live augmented reality. Introduction of 100% viewer control. First smart home lighting experience. First 24/7 multi-screen reality show. Introduction of home contestants. Immersive reality and VR broadcast. We are now pushing the boundaries of tech innovation for TV, radio, digital, social, and e-commerce. Live mobile game shows. Unique play-along shows. Intelligent live streaming of football. The future of radio.
Hey Riek, wil je even staat op verder luisteren?
Ja.
And real-time smart auctions. We operate 24/7 across the planet. We do whatever it takes to be in the lead in this ever-changing business. We are Talpa Network.
Thank you very much.
Thank you, Hielke. Thanks so much. Thank you. Great to see that innovation in immersive media experiences. Thank you so much for joining me today. Okay, let's get on. So the next thing that I wanted to talk about here this morning is migration. So as a person that's working predominantly with software developers, a lot of the focus within my specific team is on building new applications and modernizing existing. But of course, customers also migrate existing applications to the cloud. Some people call them legacy. We like to think of them as classics, like classic cars, you know, things that you need to run because you still love them a little bit. So we'll talk a little bit about migration and why customers choose to migrate to the cloud. One of the key drivers here really is speed and agility. So how can I enable my organization to do less heavy lifting so that I can focus more of my scarce assets, which typically my people and my capital and my OpEx, on doing things that are higher value than maintaining infrastructure. A lot of people that work in operations, as I do, have done in the past, describe it as keeping the lights on or maintaining the plumbing, and you'll appreciate that neither of those two things are particularly glamorous, right? So we want to try and minimize the amount of effort we spend on those activities so that we can free up resources to fundamentally help our customers help you go faster and do new things more quickly and more effectively. So in helping our customers move in this way and move these applications to the cloud, we spent a lot of time thinking about what are the right tools, the broad set of tools, the appropriate tools to help customers make that change in a way which is quick and also in a way which minimizes risk. And a lot of this is not actually about application migration. It's actually about data migration, even moving databases, relational or non-relational databases, or moving data stores to the cloud. Some of our customers are doing this at really high scale. So let's take a look at some of the tools that we have for simplifying the process and accelerating the process of migrating data to AWS at high scale. A few things that I wanted to call out here. First is the existence of physical products, physical devices that can accelerate data migration at scale. We have something called the AWS Snowball. It looks kind of like a flight case that you might put musical instruments or DJ equipment into if you're going to take it on the plane, like a large, ruggedized suitcase. But inside that suitcase is a petabyte-scale data transport solution. You order this via the AWS console, you have it shipped out to your site, plug it into your network with the integrated high-speed Ethernet, decant your data into it, switch it into pickup mode, we come and collect the device, move it back to an AWS region, and then we load all of that data into S3 for you. So it's available for you really quickly. You can think about it as a kind of high latency, like days, a couple of days maybe of latency, but very high capacity, and the aggregate there is a high bandwidth transport solution. If you're really, really, really huge in scale, we also have something called AWS Snowmobile. This caused quite a stir when we, let's say, drove it into the expo hall at AWS reInvent a few years ago during Andy Jassy's keynote. It's a 50-foot container with 100 petabytes of solid-state storage into it. You drive it up to your data center or to your satellite downlink station in some cases, connect its multiple integrated Ethernet ports to your network, splurge all of your data into it at high speed, and then drive it back to a region, and we load the data into Amazon S3 for you for access. So that's a high latency, ultra high capacity, and therefore high bandwidth transportation device. If you're thinking about moving data over a network, then you can accelerate that with services like the Amazon S3 Transfer Acceleration Service, or simplify it using a new service called AWS Data Sync, which will allow you to intelligently synchronize data across on-premises assets and data stores in the cloud. You can also use our AWS Storage Gateway at slightly smaller scale to help you easily connect on-premises applications to AWS storage services using an installable virtual appliance. So combined together, these services help customers solve for a variety of different data transfer needs that they might have. One example here in the Benelux region, we have a customer called VU, which is a Belgian digital TV, internet, and phone provider. They migrated over 400 terabytes of data from their on-premises owned and operated infrastructure to an Amazon S3-based data lake. And they've done that to enable their data scientists and analysts to access that data with a variety of different analytical tools, applying compute to it as they need to in order to get analytical results in a more timely manner. So that's just one example of a reasonably high-scale data migration that's taken place here in this region. Once you've got your data, of course, you want to use that data with applications. And here we support all of the most common and popular enterprise applications that customers are running, as well as enterprise infrastructure software such as VMware. For SAP specifically, we have a family of EC2 instances called the X1 family, which offers ultra-high memory, up to 4 terabytes today, with even larger instance types to come in the future. And that allows you to run SAP's very popular in-memory database applications directly on AWS with really good performance. For Windows workloads, we've supported Windows for over 10 years now, and according to a recent report by IDC, we host over 2 times as many Windows Server instances in AWS than Microsoft do in their service. So our experience in running Windows applications is really long, and lots of customers trust us to run really substantial mission-critical applications based on the Windows platform. Over the course of the last 3 years, usage of AWS for Windows has grown by more than 400%. And here in the Benelux again, Randstad, which is one of the largest staffing and recruiting companies in the world, migrated a complete Windows environment to AWS. They're running all of their applications on the AWS platform today. Resources that can help you do this. One of the things that we believe is that the benefits of running applications in the cloud are really compelling, and this means that customers often want to get there very, very quickly, accelerating that migration process. So we provide a services portfolio as well as tools that are available within the AWS marketplace for things like third-party data migration tools or environmental assessment that can help you figure out what you've got in your on-premises environment and how you should categorize that for a migration initiative available within the AWS marketplace for you to use natively. You might all be asking, migration is a process that takes time. So if that migration takes time, what do I do whilst I'm in the process of migrating to the cloud? And the answer here, of course, is pretty much everybody that's doing that is running a hybrid architecture. They have some infrastructure, some applications, some data, some assets, either on their premises or in a colo facility or in a data center. And they want to move that to AWS. But in order to do that, they often need to extend an environment into the AWS cloud. And customers have been doing this with Amazon Web Services since day one for AWS, which was over 12 years ago. So running hybrid architectures is just a natural part of migration operations with AWS. And this is also an area where we've been listening very carefully to customers and trying to bring forward and create services that ease the process of operating these hybrid architectures. Things like network integration with AWS Direct Connect, enabling you to establish connectivity from your own infrastructure to the AWS cloud. The VMware Cloud on AWS, of course, which allows you to use the VMware tools that you're familiar with to manage infrastructure resources located in AWS regions around the world and actually see your AWS resources directly alongside VMware resources that might be located elsewhere. We have Snowball Edge, which is a version of the Snowball data transportation device that I talked about earlier, where you can run computing workloads directly on the device. So this allows you to start virtual machines using EC2 machine images and run them locally on a Snowball Edge computing device, either connected to the network or disconnected from the network. And then for a larger scale capability for running EC2 and other associated services, EC2 virtual machines and other associated services on your premises, or elsewhere for that matter, we recently announced something called AWS Outposts. This is in private preview right now, but this allows you to deploy EC2 capacity of various types into another location, which is not an AWS region. It might be a data center, it might be a manufacturing plant, it might be a really remote location like an offshore resource extraction rig in the oil and gas industry, for example. And that allows you to run compute and storage workloads with very low latency directly next to your personnel, directly next to other infrastructure that might need to connect to those computing resources. Just drilling into VMware Cloud on AWS a little bit more, this is an area where we're seeing really significant adoption today and a lot of momentum. Obviously, many organizations around the world have been using VMware virtualization and networking and management tools technology for a long time. When we announced this, we saw really rapid take-up, also seeing really rapid regional expansion of this service by VMware in partnership with AWS, so rolling it out to additional AWS regions around the world. And one example of a customer that is taking advantage of this service is Playtika. This is an Israeli gaming company that provides free-to-play games on mobile networks and social platforms with 22 million active users. They've migrated 600 game development VMs to the VMware Cloud on AWS. And they've been able to do that without changing anything about the way in which they operate that infrastructure. No procedural changes, no policy changes, just pick up those machines and run them on AWS. So, we talked a little bit there about classic applications, right? Let's talk about the new stuff, about modernization and about building brand new applications from scratch. One of the biggest trends that we're seeing here is the adoption of microservices, the idea that applications can be evolved, and I use that word very specifically, evolved, much more quickly and effectively if they are broken up into individual components. And those individual components can be incrementally worked upon, incrementally innovated through a process of experimentation. So we can change one aspect of our overall application without having to chip into a monolith, without having to chip into a large, complex code base. One of the problems with these large, complex code bases is test coverage and testing time. Every time I deploy a change into a multi-million line of code application code base, I have a really heavy testing overhead. I have to test everything in this essence, or it's very common to have to test everything. With microservices, I can understand and map the characteristics of each individual service, make a change to that service, and test that one service as a discrete unit. And as long as that one service passes tests, I can be pretty certain that I can inject it into my production environment in a way which is non-disruptive. Okay, so it gets much easier to change things if you break them up. The other characteristic of this microservices architecture is loose coupling. Okay, so we're going to create a collection of different services which have independent functionality, and we're not going to directly couple those to one another using synchronous API calls, for example, or synchronous connections. We're going to couple them using intermediary services or using async patterns. Okay? And by doing that, we can avoid failure and latency propagation within our architecture. If I've got 3 services and they're all synchronously and tightly coupled to one another, and each service has 5 milliseconds of normal latency, but then for some reason that degrades to 50 milliseconds, my 15 millisecond response time is now 150, right? And that's going to affect my users and probably be visible to them. If I use async patterns or loose coupling, I can put in place mechanisms to allow components of my application to fail in a way which is either non-disruptive or graceful. So it's a much, much more robust way to build apps. I mentioned APIs there, so that is obviously an absolutely key component of building applications in this way. We need a robust framework that we can use to establish connectivity between the different services that comprise our application. We need authentication, we need authorization, we need observability. We need to be able to see where our application users trigger downstream services, how they're performing, where errors might be present, where latency might be introduced into the system. And we also need to, I would say typically, not always, but typically, encapsulate the data for each individual service within the service. And this allows us to exploit those purpose-built database models that I talked about earlier, where we can have the right type of data store that matches the characteristics of the service that we're building. Really, really important attribute of building these microservices architectures. The final important attribute here is more of an organizational or cultural component, and that is that we can establish an ownership culture if we have this kind of architecture. We can map our teams to individual services or small collections of services, and we can engender more ownership within the groups. You'll often have heard people at Amazon and at AWS talk about this simple phrase, you build it, you run it. It's actually quite difficult to establish that kind of culture if you have a huge application with multiple teams working upon it. You naturally have questions about demarcations of responsibility and who owns what. But with this kind of model, you can more accurately match your organizational architecture to the architecture of your software. And that actually really helps you move forward things like reliability and durability of the applications that you're building. So what do we offer to help customers build applications in this way? Well, the first thing to say is that compute, which is of course the core resource that is used in application development, is a continuum at AWS. We have several different families and types of access mechanism that you can use to access compute resources. EC2 instances, virtual machines that you can spin up on the AWS cloud. Containers, a lightweight execution environment with good separation characteristics, often using container orchestration tools, which I will talk about in more detail in a second. And then lastly, serverless approaches. In the compute world, this is AWS Lambda, which I'm sure many of you will be familiar with. We launched that service just a few years ago, but it's risen to popularity amongst developers and architects incredibly, incredibly quickly. It really does change the way in which applications are built in a really fundamental way. So on EC2, briefly, we've invested here in creating a broad range of different instance types that match the needs of different workloads that customers need to run in AWS in the cloud. General purpose, burstable, compute intensive, memory intensive, I/O and storage intensive instances, as well as machines with special capabilities like GPUs or FPUs for machine learning workloads, and graphics cards for video rendering or game streaming use cases as well. So there's a broad range of different instance types. Over 190 different combinations of instance types and sizing variants, which you can pick from in order to size your application in a way which will perform well and meet your cost characteristics, required cost characteristics as well. We also support a variety of different CPU types as well. So both Intel and AMD x86 CPUs are supported. We also have our own ARM-based AWS Graviton processor, which can offer up to a 45% cost reduction on x86 architectures for scale-out workloads. So if you haven't looked at the ARM family of instances that we announced at reInvent last year, and you're running scale-out workloads with open source software engines, I would really, really, really encourage you to take a look at the new A1 instance family for those use cases. You could cut your bill really, really substantially by doing so. So in containers, we've got a really complete platform for containers. It's something that we've been investing into for a long time. As I mentioned earlier, this is a lightweight way to package up your applications, code, configurations, and dependencies into a single deployable object. They typically start faster than virtual machines or instances, and they typically live for a shorter period as well. So it's not uncommon to spin up containers on demand for particular operations that you might want to run. Consider maybe running batch operations inside a container. You can start and finish your batch operations more quickly if you take that kind of approach. And one of the keys here is container orchestration tools, something that we've spent a lot of time thinking about at AWS, and we've been building for a long, long time. The first service that we launched in this area was something called Amazon ECS, the Elastic Container Service. It's a very popular choice for customers that want to run containerized workloads on AWS, and it has really tight integration with many, many other AWS services. For example, container-level networking. You can extend your VPC, your virtual private cloud, into your container instances, having multiple containers running on the same machine that are connected to different VPC subnets and therefore isolated from one another through this VPC integration. We also integrate with the rest of the AWS platform, including things like auto-scaling, metrics, log centralization, service discovery with Cloud Map, and load balancing, of course, plus the new network load balancer for high-performance, low-latency workloads. So if you're building applications on EC2 and you want to move those into a containerized delivery model, ECS is a really scalable and simple way to do that with equivalence to the EC2 instance services that we've been providing for a long time. It's also available in every AWS region worldwide. In order to enhance that, we announced another service called AWS Fargate, and this abstracts away, hides the process of deploying and managing container instances upon which to run your ECS clusters and upon which you will then run your containerized workloads. With Fargate, we maintain a pool of capacity. You specify tasks and launch those designated with the AWS Fargate execution type, and then we will place those tasks, those groups of containers, onto a managed ECS substrate on your behalf. You don't see any instances within your AWS EC2 console, and you'll just be charged for a combination of the compute and memory resources that you use, multiplied by the amount of time that you use those resources for. So you could think of it as a serverless, because the servers are invisible, a platform for running containerized workloads. Customers are already using this service to run tens of millions of containers every single week. So it's been very, very popular, and usage has scaled really, really quickly following the launch. And we have more recently announced a service called Amazon EKS, and this provides a managed services environment for the most popular open source container orchestration tool, which is called Kubernetes. Many of you will be familiar with this. Many of you will be using it, I'm sure, for establishing a development environment which is identical to a production environment that you might run elsewhere, either in the cloud with AWS, because it's very popular and common for customers to run Kubernetes directly on EC2 resources, or perhaps on your own premises. And what we're doing here is assisting customers in minimizing the heavy lifting associated with running Kubernetes. We are integrating it with other AWS services. For example, there is a driver to integrate VPC networking with EKS in a very, very similar way to the way in which container-level networking works on ECS. We're actively contributing all changes that we make to Kubernetes in order to make it operate within our managed services environment upstream to the Kubernetes project, and we are a board-level member of the CNCF, the Cloud Native Computing Foundation, which is the governance and management body for the Kubernetes project, and actually also for a wide variety of other associated projects as well. So AWS is a super popular place for customers to run containers. Local customers like Showpad, running over 2,500 containers on AWS over multiple regions with their content sharing application, as well as global multinationals like McDonald's. And if you ever purchased a GoPro camera, maybe use a GoPro camera, every time you use their video rendering feature to create one of their auto edits on one of those smart little films that they'll create from all of your GoPro captured footage, that rendering job runs inside Amazon ECS on demand. Each time you upload a video and press that button in the mobile app, they're running a batch job to create you a special purpose render using our container platform as well. So lots of customers using this today. And then lastly, if you move that slider all the way over, all this way over, to the event-driven serverless computing category for AWS Lambda, you'll find that we've spent a lot of time listening carefully to the needs of customers here and integrating AWS Lambda with other AWS services. Right now, we have 46 integrations for AWS Lambda, both as event sources and also as things like CI/CD tools or downstream tools for logging or workflow coordination tools like AWS step functions. There's a broad range of different integrations that you can take advantage of here to build event-driven applications, but also to make sure that you're running your serverless applications in the most production-ready environment with the right observability, logging, security controls, and everything else that you need to migrate or integrate this new application development model for new or existing applications. Of course, when we've got a microservices-based architecture, we may well end up with a mix of these different things. We may well end up with EC2 instances, containers, and other microservices components that are running inside AWS Lambda. And with this idea of enabling and engendering ownership within our teams, that's a good thing, that we allow teams to choose the right tools for the particular problem they're trying to solve or the particular use case they're trying to build for. One thing that we observed here within AWS and Amazon, where we have many thousands of different microservices comprising applications like, for example, the Amazon.com retail website homepage, was that the process of establishing connectivity between different microservices was itself becoming a piece of heavy lifting, something that required a fair amount of effort in order to sustain. So we started thinking about how we could improve this. What kind of networking layer could we create to establish consistent communications management and consistent overall management of the communications infrastructure between these different services components? And at AWS reInvent last year, in late November, we announced a new service called AWS App Mesh, which became generally available at our summit in Santa Clara last month. This allows you to establish application-level networking for all of your different infrastructure resources. The way this works is by using an open source component called the Envoy proxy and establishing a management infrastructure for those proxies that allows you to centrally deploy, manage, and control proxy configuration. You might ask why this is valuable. Well, consider a situation where you want to do a canary deployment for a microservice. Historically, that might have been an application-level configuration component, so a developer would have to write part of their application or part of their configuration to support sending 5 or 10% of their traffic to a new service variant. Okay, and different application developers might do that in different ways and with varying degrees of reliability, let's say. With App Mesh, you can establish things like traffic distribution policies centrally in a standardized way. You can say, introduce service variant B prime and send 5% of my traffic there. And that's done by injecting a configuration directly into the proxy. So the application, well, not only does it not need to be changed, it doesn't actually need to know that a new service variant has been introduced. And at scale, where you've got large numbers of microservices, that can be a really, really valuable capability to have in the environment. There are other components and other capabilities as well, but traffic management is a really important attribute of that service. Serverless, very, very broadly deployed. We have lots and lots of customers that are using AWS to build and deploy serverless applications today, and we have lots and lots of customers that are doing this in production. Customers like Capital One would be a great example, where they're moving applications from mainframe directly into loosely coupled serverless components using Lambda, Kinesis, and a broad variety of other services, as well as Philips IT Digital here in the Netherlands, who are using AWS Lambda together with our API gateway and have built their own customized service discovery capability using Lambda to map and report on where individual services are within their architecture. So lots of customers doing really, really interesting things in the microservices area. Jump away from applications and return to databases and talk about that briefly. So another major trend that we have observed here is that customers are moving away from proprietary database engines to more open alternatives. This historically has been driven by high cost, the proprietary nature of some of these enterprise databases that have existed for a long time, and also the kind of lock-in based sales tactics that are used by some of these enterprise database vendors have increasingly grated on our customers. They haven't been aligned with the needs of customers, particularly Oracle, but increasingly Microsoft as well. So customers seeking to move away to open source database engines, it's a really popular trend, a really substantive trend that we see. And we support these open source database engines on our RDS service, on the relational database service that we provide, as well as a new engine that we've created within AWS called Amazon Aurora. This is actually the fastest growing AWS service in history, a service that customers really, really like. It offers many enterprise database characteristics and features, such as rapid failover, really high data durability, but it comes at about 1/10 of the cost of comparable licensing and operational costs for databases with those enterprise grade features. And that's led to it, as I said, being really rapidly adopted by customers. Here in the Benelux, Coolblue, who are a really large and fast-growing e-commerce company here in the Netherlands, in Belgium, they've migrated their on-premises MySQL clusters to Amazon Aurora, and they've also taken advantage of read replicas in the Aurora architecture to enable them to dramatically improve performance. They can also scale their database up and down programmatically using our scaling API to add more capacity at certain times of the day when they need that, and remove it at certain times of the day where they want to optimize for cost. So very, very, very popular service with our customers. As I mentioned earlier, the other trend that we see here outside of relational database migration to AWS is the use of purpose-built databases. And this is a really important component of microservices, as I mentioned earlier, where you might want to encapsulate a specific data store inside a service that you're building. We have DynamoDB, which is a high-performance key-value database with really broad adoption, used for applications that need consistent millisecond latency performance characteristics. Recently announced DocumentDB. This allows you to use the document-oriented paradigm, schema-free, with flexible indexing. It's very popular for use cases like content management, personalization, or as the backend for web or mobile applications. Then we have Elasticache. This is an in-memory cluster that you can establish to run Redis or Memcached in your environment for accelerated application performance. We have Neptune, which is a graph database, enabling you to establish the kind of graph schemas that are very popular in social networking and fraud detection and other use cases where you want to ask questions of your data that relate to relationships. Then we have TimeStream, which is a time series database for efficiently collecting, synthesizing, and providing analytical insights over really fast-moving and high-volume time series data. And then lastly, we have QLDB, which I'm going to return to and talk about in a little bit more detail in a second. Dynamo, we recently added several new features to Dynamo, global tables, on-demand backups, point-in-time recovery, as well as elastic scaling with read-write capacity on demand. So it's no longer necessary to size your DynamoDB clusters and specify a throughput level. Instead, the clusters will respond dynamically to the amount of traffic that they're seeing and scale up and down in response to those changes, enabling you to pay less for capacity because you're only charged for the read and write capacity that you're actually consuming at any particular point in time. As I mentioned earlier, it's really, really widely adopted amongst many, many high scalability use cases, incredibly popular in areas like mobile game development or high-scale web applications. I mentioned that I would return to QLDB, and QLDB is one half of a couple of services that AWS recently announced that are intended for blockchain use cases. Okay? Blockchain is, let's just say, an area that is rich in hype. I really expected more people to agree with that. I hope you agree with that. An area that is rich in hype. So lots of people are interested in it. But actually, if you really drill into the use cases that people have for blockchain, some of them are kind of ephemeral. They kind of disappear when you ask why you need to use that particular type of technology. Having said that, there are a couple of use cases that we think are significant and where customers really are putting this technology to work. The first is in ledgers. So this isn't so much a question of distributed trust. It's more a question of proof of data lineage. So I want to establish a database, a record, where there's no question about whether or not that data's been changed or modified. I want to be able to cryptographically prove that my data is a complete record and that all changes to that data have been recorded and can be inspected. And that's precisely what the Amazon Quantum Ledger Database, or QLDB, does. It provides a cryptographically verifiable log of all changes to all data within the database that you can inspect via an API. Each change is cryptographically signed and then stored on a blockchain. Now, those signatures are stored on a blockchain, so you can establish whether or not anything in the database has changed. That's one common use case. And then the second common use case is smart contracts and distributed ledgers where trust is distributed. And here we have something called the Amazon Managed Blockchain Service. This allows you to establish a Hyperledger framework, Hyperledger Fabric or Ethereum blockchain infrastructure, and to use that as the core of a distributed ledger application together with smart contracting capabilities. So if that's your use case, I recommend taking a look at this service. So a big movement for database freedom with AWS. Now, of course, there's more to this than just databases. You want to do something with that data. So let's quickly move on and dive into analytics on AWS. This is a really expansive area where customers are using AWS for increasingly demanding and increasingly valuable applications. They're looking to extract more value from their data. And in order to help customers do this, we have a really broad portfolio of services for data engineering and analytics. Real-time streaming analytics is a very popular area, but ultimately what customers are seeking to do is aggregate data inside reliable data stores that they can ask questions of. Amazon Redshift is our petabyte-scale data warehousing engine that you can run on AWS. This is an area that we've recently announced an enhancement in, a concurrency scaling feature, where we can dynamically add capacity to a Redshift cluster in order to execute queries more quickly. On streaming analytics, we have a service called Amazon Kinesis, which enables you to ingest data at high speed and high volume, ask questions of that data in real time and receive results in real time, as well as funnel that data to persistent data stores with a service called Kinesis Data Firehose. And together, these services mean that cloud data lakes really are a very popular use case for customers and something that we regard really as the future of analytics. We think this is the normal way in which customers will aggregate and ask questions of data in the future. And for that, of course, we have Amazon S3, which is by far the most popular choice for customers that want to establish data lakes, offering really high levels of durability, availability, and scalability, security and audit capabilities, including object-level control over your data, as well as a really broad range of partner integrations where you can use the service to move data in and out of the platform from a variety of different software tools. Most recently, we've been focusing on trying to simplify the process for customers that are establishing data lake infrastructure. And for this particular problem space, we created a new service called AWS Lake Formation. This allows you to build and manage a data lake in a much simpler and more streamlined way, cataloging your data, using machine learning capabilities to figure out what kind of data you have, what the structure of that data should be within the lake, and then moving that data into AWS in a manner that ensures that security policies are enforced across multiple different services. I'm going to introduce another customer to the stage now to talk a little bit about analytics. This is a customer that knows not only about growing data, but also about starting and growing a business. If you haven't heard of the term, Unicorn is a startup that's achieved a valuation of more than $1 billion. Belgium's first unicorn was born this year. This is a business called Calibra. It's a data governance company that helps customers understand, find, and develop more trust in their data. To hear a little bit more about what they're doing, I'd like you to welcome Stan Christians to the stage. Stan is the CTO and co-founder of Calibra. Stan, please join me.
Thank you. Hi, everyone. Thanks, and thanks for coming. I have to say I was a little bit nervous when I was first asked to come speak at this event, because unlike normal presentations, this is talking about some of the Calibra journey in the cloud itself. Now, I decided, of course, to do this because it's a great opportunity to showcase Calibra, but also because it's a learning opportunity. And I think that's why we all came here, right, to learn about this next big thing in the cloud, because we believe that the cloud is fundamental to digital disruption. So we started Calibra about 11 years ago in a garage, and I learned yesterday, just like Amazon started also in a garage, just like Amazon, there was impressive growth. We also had amazing growth. We started with 4 people, now we're 440. We started in a garage, now we're in offices in 10 countries. We have about 7 years of triple-digit growth. We have hundreds of customers of the top brands, and they all choose Calibra because they see this digital disruption happening right now. And this is a study by McKinsey that shows that 8% of the companies believe that their business model, aka how they make money, will survive the digital disruption. In other words, there are 92% of the companies who believe that they are the next blockbuster about to be Netflixed. And the people in this room, you all know that digital is more than just plugging a printer into the internet. It's about offering a digital product or a digital service and or getting really close, knowing really a lot about your customers. And the only way to do that, you can't hire people endlessly to do all of this. The only way to do this is to use data and analytics. Now, there's some challenges that organizations are going through when they're trying to become digital. And I've plotted these out on these two axes. One is the trend towards speed, on the control towards freedom axis. When you talk to data scientists, all they want is freedom, right? Give me all the data and I'll figure it all out. But organizations are still oftentimes on that left-hand side. This is decades ago, but it's still true, where they tried via centralized reporting, had to wait 3 years for a data warehouse to be spun up, another 6 months for their report, then they went self-service BI, and now they're going full in on data lakes. And then another axis that is a challenge for companies is the offensive data strategy, how you make money using data, versus the defensive data strategy. Too often times I see data leaders who are either too much on the defensive side, focusing, for example, only on GDPR or regulatory, versus focusing too much on how do I make money from data without taking into account the risks. And the sweet spot, of course, is exactly somewhere in the middle of this. And this is why companies come to Collibra, because Collibra is positioned in that sweet spot. We are not a data management company, which you see at the bottom, and we are also not a BI company. We're somewhere in the middle. And it's taken me 11 years now of practicing my pitch on how to explain Collibra, so if you permit me, I'll do that in 30 seconds with you as well. Given that you're all here, and there's a lot of you here, I'm assuming that you've all bought something online, right? You've bought a book online on Amazon, for example. It's easy, you search for it, you pick your book, you put it in your shopping basket, and the next day it's already in your house. Well, I will bet you that it's easier for you to do this than to find your own data in your own organization. And that's the problem that Collibra solves for our customers. We're that internal catalog of data assets in the company, that internal data marketplace. Now, think about this for a second. Imagine that you ordered the book online and it didn't show up. It's the wrong book. It's damaged. You can't reach the seller. How many times would you use that service? Twice, maybe 3 times. And then quickly you would lose trust in that service. And that's the governance component of Collibra, which provides you with that trusted data marketplace in your company. Now, when we were 4 people in that garage, it was easy to do data in Collibra because data was just seeing the other people work, right? Now we're about 440 or something people, and we've become a little bit more like our customers. So in the last, let's say, year or so, maybe 2 years, we've started eating our own dog food. We've started drinking our own champagne. We've started to become a little bit more serious about data. And then just like our customers, we noticed that data is massively commoditizing in the clouds. You don't run your own electricity. You don't run your own water. Why would you run your own data, storage, and compute infrastructure? And in my perspective, this is a huge new platform war that is ongoing. Right? There's 3 big vendors that are all competing with each other to be the operating system for the web, if you will. Now, you're all here, so you're all believing that this is the place where the next big winner is going to be defined. We at Collibra also believe that data management is commoditizing in the web, which is why we chose to go full in on a strategic technology partnership, as well as use it for our own internal purposes. And just like our customers experience challenges in moving data to the cloud, we've also seen the same challenges. What do I do with my legacy? Right? Do I snowball them in with a big truck? That sounded pretty cool. What do I prioritize moving to the cloud first? Which of those classic applications, which of the classic data is most important to move into the cloud first? How do I wrap AI and machine learning projects around it to actually do analysis on that data that we've collected? And last but not least, because again, as you all know, the cloud is just somebody else's computer, they're still stored somewhere. That machine, the data is still stored somewhere. It's flowing through jurisdictions. And as it is doing so, there are laws that you need to abide by, and that regulation, from our vantage point, is only increasing as things like GDPR and other types of data breaches pop out. So these are some challenges that we're seeing in moving to the cloud, and that we've also experienced as Colibra. So what we did last year at AWS reInvent, I think there's about 3,000 people here. reInvent in October, Vegas had about 50,000 people. Don't think I've ever seen so many people together. And we introduced our solution that we also use internally at Colibra, which gives us end-to-end data shopping. Right? You go into Colibra, you search for data, for example, customer data, presents you with some search results, and then you select this one, I want it in my shopping basket, you check it out. Somebody maybe approves this because the reason why you want to use this data is compliant with such and such. And then the Amazon infrastructure helps us take care of the rest. In our case, for example, we have data from Pendo, which is a product usage tool that we use to see where people click and how they flow to the software so we can improve it. And then we move that data together with, for example, Salesforce data into S3 buckets. We move it Glue, we put it in Redshift for further analysis. And this infrastructure, the shopping basket, is also including direct connectivity into AWS IAM, Identity Access Management. So we know who is permitted and who has access to that specific data. And this setup is giving us a lot of benefits. It's reliable, more so than we could ever build ourselves, right? It's flexible, it gives us a lot of speed, because we can set up that warehouse from one day to the next, rather than waiting for ordering a server or any other kind of solution. So these benefits that it is giving us are unimaginable if we have to do them ourselves. Like I said, we don't want to run our own electricity either. And I want to give you a very specific example. We have many more benefits, but this is a very specific benefit that I wanted to highlight. So as we sell our software, you can imagine when you're buying a car, you want to kick the tires, right? You want to drive it a little bit. So our sales engineers constantly have requests to spin up a demo instance, a POC environment, and so on and so forth. And it used to be that this had to be a ticket that went into cloud operations, and then maybe, depending on their availability, they would ready that environment in a short time. But now, what we've done is we've set this up using EC2 instances, so the sales engineer can just request that instance, and about an hour later, it'll be ready with all the data and everything inside of it. And here's a chart as to how much this one thing that we've done with AWS is saving us. If we would do it with on-demand instances, that's the top line, reserved instances is the middle line, and the spot instances is the bottom line. So for us doing this, next to the flexibility and the speed it is giving to our business, it is actually 1/5 of the cost. We're saving 80%. Again, next to all the other benefits like delivering flexibility to our business. My time's out, but I do want to leave you with some key takeaways. We all know, I think that's why you're here. We're all here because we realize that digital disruption is happening and data engagement is the answer. You will need to combine an offensive and a defensive data strategy. If you do one too much, you'll expose yourself to risk or not add enough value. Your journey will vary. And this is why you are here, to learn how you need to do this for your organization. And last, but definitely not least, the cloud is a fundamental instrument to going digital. So if you want to know how you can help your business through digital disruption right now, just go online and set up your data infrastructure. Thank you.
Thank you. Thanks for joining me, Stan. Okay, let's get on and talk about one of the hottest areas in technology today, which is, of course, machine learning and artificial intelligence. For a long time, we've said that our goal at AWS is to put ML capabilities into the hands of every developer and data scientist in the world. And for even longer, Amazon has been using this technology at the core of many of the products that we provide today. So you'll be familiar with retail recommendations on the Amazon websites, which have been in operations for over 20 years, but also more recent innovations like natural language understanding with Amazon Alexa, or the retail experience within Amazon Go, which is walk in, walk out shopping, walk into the store, pick up what you wish to purchase, walk out, and can only be described as auto-magically charged for whatever you've removed. So we've got a long heritage in doing this, and at AWS it's been a focus for us now for several years, and that has resulted in AWS becoming the most popular place for customers to run machine learning workloads. We have tens of thousands of customers that are doing this today. Customers like Skin Vision here in Amsterdam, they are using ML applications built on AWS to detect and diagnose skin cancer. Or Marinus Analytics, they're using Amazon Recognition to detect, investigate, and rescue human trafficking victims. So not only is this impactful technology, but it's actually really capable of delivering benefit for society at large as well. If we think about machine learning at AWS, we think about it in terms of 3 different stacks. The bottom layer of the stack is low-level frameworks and infrastructure. The middle layer is simplifying platform components that make it easier for developers and data scientists to get started with this technology. And the top layer is really simple to use, highly abstracted services that make it easy to put human-like intelligent characteristics into the applications that you might want to build. At the bottom, we've invested in creating Amazon P3 and P3DN instances, which provide low-cost, high-performance, floating point acceleration capabilities for building and training large-scale machine learning models. And we've also invested in integrating popular frameworks with this low-level infrastructure, supporting the 3 most popular machine learning frameworks, as well as supporting 2 different popular interfaces for deep learning neural network models. More than half of our customers will use 2 or more frameworks in a day of machine learning work. More than half of our data scientists and ML users will do that. And they'll mix and match between MXNet, PyTorch, and TensorFlow, as well as using these abstraction layers to simplify the process of defining neural network models as well. So we have worked hard to integrate TensorFlow and optimize TensorFlow for operations on AWS low-level resources. Today, around about 85% of all TensorFlow workloads running in the cloud run on AWS. Customers like Siemens, like Snap, the makers of Snapchat, use TensorFlow on AWS at scale in order to add ML capabilities into their applications today. Some of the most recent work that we've been doing is in optimizing TensorFlow for scale-out use cases. So we've managed to dramatically improve the scaling efficiency of TensorFlow with very large GPU clusters. It's really delivering you significantly better cost efficiency for training large neural network models with large data sets. So if that's your use case, please take a look at TensorFlow on AWS as a solution to drive down cost. Now, having talked about training costs there, I'm just going to point out that actually the majority of machine learning costs come from inference. So after you've trained your model, you're going to use that to make predictions about the real world based on data samples that you're receiving. That might be facial recognition, audio to text conversion, or some other custom use case that you have in mind. And we're working hard to try to help customers minimize the cost of these inference workloads. Consider this. The Alexa language model gets retrained regularly, but every time a customer says Alexa, then there's an inference invocation, and customers around the world are doing that all the time, of course, so inference costs add up very fast at scale. So in order to try to help customers reduce the cost of inference, we have a couple of new innovations that we recently announced. The first is Amazon Elastic Inference. This allows you to attach smaller GPU capabilities, rightly sized for the particular inference workload that you have, to lower-cost EC2 instance types, so the M5, for example. And then AWS Inferentia, which we will deliver late in 2019, is a custom-designed machine learning inference chip that AWS has developed, which will deliver inference cost reductions of a factor of 10x. That will come later this year. So whilst there's a lot of activity in the bottom level of this stack with these framework integrations and optimized hardware, the real challenge is that there just aren't that many expert machine learning developers out there. There aren't that many machine learning experts out there, full stop. So in order to try to make machine learning more accessible, we created another service called Amazon SageMaker. And this is a complete platform for training, well, building, training, and deploying machine learning models. It provides a data preparation and integration environment. It provides built-in algorithms. It provides a really simple way to train with those algorithms against your own custom data sets. And then it provides a complete deployment and operational environment for running inference at scale on EC2 instance capacity. A very, very popular service. Already more than 10,000 customers are using this. One of the most famous of those customers is Formula One Auto Racing. They've standardized on AWS machine learning services. I think this is a pretty hot topic in the Netherlands right now, with this idea that you might bring Formula One racing back to the country and allow Max Verstappen to race on his home territory. But F1 are using AWS machine learning services, including SageMaker, to enrich the fan experience, to predict the likelihood of certain events happening within a race, or to predict the likelihood of certain events being successful. How likely is it this overtaking maneuver will work out in the way in which the overtaking driver anticipates? Calculating that in real time using machine learning models and injecting it into their broadcast is one of the use cases that they have built using SageMaker. Then if you go further up the stack, you'll find here a collection of services that are intended to add human cognitive abilities to your applications in the simplest way possible, across areas such as image recognition with Amazon Recognition Video and Amazon Recognition, which is for static images, as well as Textract, which is a machine learning-powered document analysis and text extraction capability. You can feed documents into it, train the system about the documents, and it will automatically extract data from those documents in a structured way using deep learning capabilities. And then in speech and language, we have a suite of services for voice generation. Werner just announced Arabic support for Amazon Polly this morning at our summit in Dubai, which is a couple of hours ahead of us here in Amsterdam today, as well as other services for transcription, for translation, for understanding natural language, even in specific domains like medical, and also for building natural language chatbots. And in this same category of really simple to use services, we have announced and have in preview 2 more new services. Amazon Forecast, which is an accurate time series forecasting service based on the same time series forecasting modeling that is used elsewhere within Amazon.com. Surely you appreciate that for a retail logistics provider like Amazon, time series forecasting is a really core capability. We have to know how many products we need in each fulfillment center, in each product category at every particular point in time. So it's a service type that is used really extensively within Amazon. We're going to make that available to customers in Amazon Forecast. And then recommendations and personalization, again, a technology area that we at Amazon use really substantially. That will be made available for customers as an AWS service called Amazon Personalize as well. Most of these services are in preview, and you can sign up for the previews today and learn more about them on the AWS website, of course. If you want to get started with machine learning, we have some resources here. We have a ML Solutions Lab, which is a professional services engagement to accelerate use of machine learning within our customers. It pairs your team with Amazon machine learning experts, bringing them to you to help you build ML workloads, ML applications based on your own custom data. And if you're more interested in upskilling your developers, we also offer the Amazon Machine Learning University, taking our internal machine learning training that many, many thousands of developers across Amazon have benefited from, and making that available for customers to use directly via our digital learning platform. So check that out if you're interested in developing your own or your team's machine learning skills. Talking about getting started with ML, we also have a couple of interesting physical products that are intended to allow developers to ramp up their ML skills. AWS Deep Lens. This is a deep learning-enabled video camera. It allows you to be taught how to build and deploy image recognition and image processing capabilities using deep learning neural networks. Inside the device, there is a CPU and a small GPU. You can train a model in SageMaker for image classification, image recognition, facial detection, hot dog or not hot dog detection, actual valid use case, which is supported. Deploy that down onto the device and run your machine learning image processing workloads at the edge. And then most recently, we have this, the AWS Deep Racer. This is a fully autonomous 1/18th scale race car designed to help you learn about reinforcement learning. Reinforcement learning is one of the hottest ML fields right now. And in this reinforcement learning model, the models learn in a simulator. So we create a simulator of the real world, in this case a racetrack, with a simulated view of the racetrack. And we train an image-based model in the simulator, spitting out a model that can then be deployed onto a physical car. And then you can race this car around the track. And we've created the world's first autonomous vehicle racing league, global autonomous vehicle racing league, in order to help customers win something by showcasing their reinforcement learning skills. Not only do we have this, but we have a brief video that will show you a little bit more about it. So let's take a look at that video right now. It's from our friends over at Intel.
Hello everyone, I'm Ryan Marine. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning.
So you can participate in this today. We have a Deep Racer Amsterdam Speedway, which is built up in the expo all across the back of the keynote hall here, where you can compete. But when the service GAs, which will be in the near future, you will also be able to virtually train your model in a simulator which will exist within the AWS console, and participate in the virtual events globally from the comfort of your own workstation or laptop. So please take a look at that service when it GAs in the very near future. OK, great. So the next thing I want to do is move on from very small cars to some of the largest vehicles on the road today. And our next speaker is in the forefront of innovation in the commercial vehicle management space. WABCO is a global leader in advanced technologies to improve safety, efficiency, and connectivity of large commercial vehicle fleets. So to tell us a little bit more about that, I want to introduce Philippe Colpron, who is the VP and Global Leader Fleet Solutions at WABCO, to the AWS stage. Thanks, Philippe.
The commercial vehicle industry is on the verge of a new era. The Internet of Things is radically changing how we transport goods and people. Growth in big data will increase vehicle intelligence. As critical information flows between vehicles and the world around them, trucks, buses, and even trailers will become progressively more autonomous, while reaching new levels of safety and efficiency. There is one company already at the forefront of the technologies that will mobilize this vehicle intelligence. We are WABCO.
So good morning. I'm Philippe Colpron, leading this fleet solution business at WABCO, and I'm very happy to be here at the AWS Summit. It's exciting times for the automotive industry, exciting times for the logistic industry with all of these digital opportunities that are rising ahead. So WABCO, as you saw in the video, is a leading technology provider for the commercial vehicle. We've been around for 150 years, and you will find some WABCO on a majority of the truck, trailers, buses that you will find on the road. We operate globally, employing 16,000 passionate employees, delivering close to $4 billion. And as the industry is moving towards vehicle autonomy, we provide the technology to make that happen. We provide technology to continuously make those vehicles smarter. But I believe that we can leverage a lot of that for improving the efficiency of fleet operators today by allowing them to make the right decision, fact-based decisions, aggregating those data in order to help in real time improving their operations and gradually automating their activities. Still today, in continental Europe, over 70% of goods are transported over road by commercial vehicles. And you and myself, we are, as customers, increasing our expectations in terms of the usage of those goods. So we want to make sure that we improve the efficiency of that road transportation, because it is an industry which is at the heart of our economy. And we believe that every unnecessary kilometer which is driven, any trailer cargo which is unoptimized, or any downtime that can happen with the vehicle can be eliminated. And we want to tackle that 1 trillion euros in inefficiencies that we believe are happening in the logistic industry around the globe. So we leverage connectivity in order to do that. We put telematic units on the trucks, on the trailers, in order to make them connected devices that we can leverage the onboard computers on the vehicles that collect the data on the road, and that can also connect to the drivers, to the cargoes, and to logistic ecosystem in order to provide that information to people that can do something about the efficiency of the operations. Delivering in real time the information to transport operators, aggregating those data, pre-digesting it, and automating some of the tasks. We have started that journey 25 years ago, and as you know, the current technologies, the current cloud applications were not existing back then, but we now already have to manage over 1 million data inserts per minute. Anticipating that we're going to be connecting to more vehicles, anticipating that all our new applications require further processing power and artificial intelligence, we had to think of the future architecture. We have to anticipate that we need scalability in our system. And that's why we started the journey with AWS 2 years ago, in order to leverage AWS's managed services and also the latest technologies that we can provide. So we can focus our time on where we can create differentiation. We can spend our time talking to the customers, understanding the needs, developing solutions that can really improve their efficiency. That we can create differentiation and innovation, and most importantly, that we bring that innovation fast to the market. I believe that these new architectures and these new solutions really give the ability to act fast. So you can see here the architecture of the latest product that we're introducing, where we're introducing end-to-end from installing IoT devices on the vehicles up to having web applications in front of the customers supported with a cloud architecture. And to develop that end-to-end solution, we could actually reduce by half the time from ideation to time to market. And the 3 core services that we would like to highlight that we leverage from AWS is the IoT core, where we can have in a central management of all of the IoT devices that we are having on the road. DynamoDB, that allows us to store all of that vehicle information into the cloud, and then EC2 Instances that allows us to have all the computing power in a flexible way for running our different data lake clusters and allow us to do our big data algorithms and analytics. So the product that we're launching today, which is based on this architecture, is what we call the trailer fit. In order to put eyes on the trailer, for many years we've been spending time putting eyes on the truck because that's where the driver is, that's where the engine is. But we believe the trailer is equally important. Us, as consumers, we want to know if the cargo has been transported in good quality. The logistic industry, if they want to improve those empty trailers, need to understand if the trailer is full or empty, which we can detect through the weight of the vehicle. And the transport operators want to make sure they have no downtime, that they can see if there's any issue with the vehicle, and that we can predict and anticipate. So we can actually run full diagnostic systems on our ECUs. We can retrieve the information from the sensors, and in case we would require the technical expertise of a mechanic, of a technician, the fleet can share in a secured way that information very easily, for example, with one of the 3,000 authorized WABCO service partners, in order to ensure the vehicle stays on the road, maximizing uptime and improving road efficiency. So this is just one example of the suite of solutions that we want to bring, and that we are bringing to the fleet ecosystem. A suite of solutions that is intended to reduce inefficiencies, and this is how we believe that we're looking into our business development. We talk to the industry, we talk to the customers, and try to identify where do you have waste. And when we identify waste, we'll think of the next application that we can introduce into our application. Most of those products require more data, require more artificial intelligence, and more computing power, and that's why we believe that technology and cloud is important to realize that portfolio. A complete portfolio that allows to improve the efficiency of road logistics. And that allows us to have a new type of discussion, new type of partnership with transport operators that allows us to increase the connecting points within the logistic ecosystems to make it improvement and fueling our vision to make road transportation radically leaner, greener, and safer. Thank you.
Thank you, Philippe. And you can find out more about the work that WABCO have been doing with AWS, particularly in the IoT domain. If you head over to the back of the expo at some point during the day, you'll find some of their technology available for you to take a look at there. Thank you, Philippe. So if you want to learn more about AWS AI and machine learning services, which I was talking about before I invited Philippe to stage, just visit ai.aws in your internet browser or telephone, and you'll find a resource center there which has a lot more information about all of the services that I covered previously. So I'm going to wrap up briefly by talking about a final area in which AWS is working, which is in edge computing. And we'll come to talk about what the edge means, I think, first of all. So in the old days, we used to see that most computing was aggregated either into large data centers with x86 or other forms of semiconductor hardware. Plus we had desktops and laptop computing devices, and that was pretty much the landscape. Today, the computing landscape is way, way, way more diverse than that. We have microcontrollers and semiconductors in all kinds of products. And actually, our CTO, Werner, said a few years ago that it's our long-term vision that every device that has the ability to provide energy to a CPU will probably end up having a CPU of some type in it in the future as the cost of silicon and the costs of connectivity fall. McKinsey and Statistica have forecast that by 2025, there'll be some 7.5 billion connected devices, which is more or less 10 devices for every single human being on the planet, just slightly less than that. So data is coming from all kinds of different edge devices. And there are some fundamental challenges in collecting data from this diverse array of computing devices that are distributed globally. You have physics, speed of light issues, Earth curvature issues, radio connectivity issues. You have economics, the fact that overcoming those challenges costs money if you want to use a satellite or other infrastructure to provide connectivity to a connected device. That can be costly. And you also have regulatory and compliance concerns that you need to overcome. Things like operating your devices in locations where they provide really high value. Take in medicine, for example. It comes with a whole set of regulatory and compliance requirements that you need to meet. And Philips Healthcare here in the Netherlands are a really good example of a customer that's overcoming some of those challenges today. So collecting data from the edge can also be a challenge. In order to address this, we've built a platform for IoT, for Internet of Things applications. AWS IoT Core, which Philippe mentioned in the course of his presentation, is one component of the services that we provide. But we also provide device software components, Amazon FreeRTOS, which is a derivative of the popular microcontroller unit MCU operating system with the appropriate SDKs to integrate your low-power edge computing applications together with the AWS IoT Core service, as well as SDKs for more, say, performance-rich edge devices that might be running Intel or ARM CPUs as well. And then we have a set of data services enabling you to collect and respond to events that might be happening on your IoT fleet, IoT events, site-wise, and analytics, plus a suite of control services. Really, really important here, of course, is device security. And to help customers overcome that challenge, we shipped a service called IoT Device Defender, which uses anomaly detection with machine learning to figure out when you might have a device which needs to be maintained, which might need a new software deployment to be sent to it, and a secure mechanism with IoT device management to get those software updates out to your devices in a reliable and robust way. So there's a complete platform there for building IoT applications that you can take advantage of course. Many, many customers using this today with millions and millions and millions of devices connected to the AWS IoT service via our endpoints around the world. One of the larger customers here in the Netherlands that's using this service is Philips Healthcare, who I mentioned earlier. They run their Health Suite platform on AWS. They have around 30 petabytes of patient data stored in a way which meets regulatory requirements, which was generated by 390 million different imaging studies that have been run on patients. So very high volume. They're using AWS IoT for device management for connected devices in these medical applications that they provide. And we have a variety of other customers as well that you can see on this slide. Okay, so I'm going to wrap up the keynote. The first thing I want to say is thank you very much for joining us for this morning's extended session. I really appreciate it. I hope you've learned something from the customer speakers that were kind enough to join me on stage to talk a little bit about their AWS usage here today. I would personally love to get your feedback on the event, as would the rest of the AWS team. Please don't forget to drop in and attend the breakouts today. The main thing that I would like you to take away from this morning's session is that no matter whether you are a brand new company that's just getting started in the cloud, a 200-year-old enterprise like PostNL, or you're operating in a highly regulated market, you can build applications to service your needs using the AWS platform. Thank you.
The keynotes have now finished. Check the mobile app for your next session.